Hey there, I'm BogdanBudaca and welcome to my channel. Thank you for joining me for another mind workout, and I also hope that you keep safe and you keep learning. So today I thought that we could go over another cool little problem. We will be encrypting some more messages. A couple of videos ago we played around with Caesar's cipher, and I will link to that video as well, but today we will be using a substitution cipher. Okay, so of course whenever you feel that you can continue on your own, please pause the video and do so. So let's dig right in. Our mission for today is to write a program that implements substitution cipher. So what that is, you can look up online as well. It's pretty interesting. We will be using a simple substitution cipher by way of what's called the substitution alphabet. So how that works is we can take the 26 letters of the alphabet and we can scramble them around, and that will be our key, our substitution alphabet. And we will map each letter of the plain text to the encrypted letter in the ciphertext by looking at the index position of the substitution alphabet. So what I mean is, if, for example, this is our substitution alphabet and our plain text contains the letter A, that's index 0, that's the first letter of the alphabet. So we will just look at index 0 of our substitution alphabet and we will replace the A with a J. Okay? If, for example, our plain text contains a B, we will look at index 1, so the second position in our substitution alphabet, and we will replace the B with a T, and so on. For example, if we have a Z, we will replace it with a Q in our case. So I guess it's now pretty obvious how this works, fairly straightforward. So we do have some constraints and some checks to perform on our key. So it must be 26 characters long because we're using the letters of the alphabet, all the letters of the alphabet. It must be only letters because that's the only thing we're working with. And we mustn't have any duplicates, and the plain text letter cases must be maintained when converting to ciphertext. Okay, so if we have lowercase, we convert to lowercase. If we have uppercase, we convert to uppercase, and this will be regardless of our substitution alphabet. We will be kind of case agnostic for that. So that won't matter for us. So okay, let's see how we can draft a small algorithm for our work to get started. So the first one would be check for arguments. So we just want to check that we have an argument for our program. When we run our program, we will have the argument, which will be our key. So check for arguments, then check key validity. So here we could do check that it's 26 characters long, 2.2, check that it's only letters, 2.3, check that there are no duplicates, 2.4, actually that will be further down our code, so we can go to 3. So here we have a valid key. Now iterate, actually get the plain text from the user, iterate through the plain text and convert. So here we will map to the substitution alphabet. We will make sure to maintain, yeah, that's fine, lower or upper case for the plain text. Okie doke. Then if everything goes well, we output the ciphertext. Okie doke, so this could be a starting place for our work. So let's actually get to it. So standard io.h, include that. Then our main function, main, here we have int argc argument count, and then our array of char arrays, strings. So here we can already start checking. So argc equals to 2. So we need 2 arguments. The first argument is the program itself, and the second argument will be our key. And str length. So we could also check the length, 26 characters here. I think we need a string library .h str length function of argv of position 1, so index 1, the second argument. So if this checks out, we're fine, else. And here let's print usage. We will call our program substitution key, new line, and we will return an exit code of 1. Okay, should be the error. Okay, so here we're fine, and we tackled the first 2 points, actually 1 and 2.1. Now we want to check that it's only letters and that there are no duplicates. So how can we do this? So what I propose is we start iterating. So a for loop, we initialize I and int I to 0. I is less than str len of argv of position 1, I plus plus. And here what I propose that we do is use another for loop, so a nested for loop. And it's quite simple to evaluate that it's a letter, so we can just use the is alpha function that comes with the C type library. So let's go ahead and include that. So you'll see that we can use a function is alpha and just checks if our character is an alphabet letter. But to check if there are no duplicates, basically what I want to check is the equality between 2 characters. Okay, so what I propose here is when we loop the first time, so the outer loop, when we're at the, for example, the first position, let's say that our key will be this one, which is just the basic alphabet. So if we have this as our input key, when we're looping here at the first position, we have A. I just want to go through all the other characters and compare it to the first character. Okay, so what I mean by that is add another for loop here, int j equals 0. We have another integer j is less than str len of argv of position 1, j plus plus. This will be our inner loop. So when we're at the first character here, in our inner loop, we will iterate through all the others. Okay, so what I mean by that is, and here I want to start j at I plus 1. So when I is 0 and it starts with A, I want j to actually be 0 plus 1, 1. So we will start with B and so on. Okay, so when we're at A, we will actually iterate here in the inner loop through all the other characters minus the A. Okay, because we don't want to compare those, because we will actually get equality there. So we will start with the next character over. Okay, so we can actually have a printf here and get a visual of what this would look like. So I position char is C. Here we would have argv of 1 I. I actually want a new line here, so we will have it pretty so we can follow along. Here we'll have j position char and j here as well. Okay, let's see if we can get this working, get an idea of how this would look like. So gcc compile our program, output this to a program called substitution. Is that right? Substitution. Okay, so substitution. Here we need our key. Let's just take plain old alphabet. Okay, it's quite a big output, but it'll help us follow along. So let's see now. So okay, so when I is A, we have J go through all the other characters. Okay, so I is A, J is B, I is A, J is C, I is A, J is D, and so on. Okay, So we should see j as z somewhere. So here a z, and then we move over to the next one. So I is b, then j is c, and so on, b, d, and so on. Okay. So basically, for each character in the outer loop, we go through all the others in the inner loop. Okay, and we compare their equality. And we start in the inner loop with the next character over. So we don't actually compare A and B and so on. And one thing here at the end, you can notice that I stops at Y, okay? So here it doesn't go any further. So I think we can tweak that by, so what I mean is, so we don't have to check for both argv1 of I and argv1 of J that they're alphabet characters. We can actually, I think we can do a small tweak here. So we can increase the span of our inner loop. And if we do that, I think we will get I to go from A to Z all the way, okay? So let's try. Okie doke. We do have I is Z here, but I see some inconsistencies with J. Where does this happen? Is I is T, J is not I is U. Oh, okay. So yeah, it just makes another blank for J. Okay, but I hope this will be fine for us. So let's give it a check. If is alpha here argv1 I mean, yep. Then we are good. Let's make a boolean, for example. Include standard bool.h. Let's have a boolean here. Bool valid equals false. Here we will just flip it to true. Else we can just reuse this issue. So just reuse this here. Oh, up. So let's arrange this a bit. Okay. So let's make sure this works. Okay, so it compiles. Works. Okay, this doesn't work. We have a number at the end. I want to try both ends. So okay, this is good as well. And of course, if we have more characters, it's broken here, so it's actually good we checked. So we need this one again. Okay, so now we have more than 26. Let's go with less. Same thing. Okay, so here, yeah, this still works. Okay, so we're good here. We do have J shooting a few blanks, but that doesn't affect us. We still do check the code. So what we did there, instead of actually have to check for both argv1 of I and argv1 of J, we just check for argv1 of I. We could have just left this out, but we just had to check for both. So I'm not really sure which would be the best approach, but I think this is cleaner for us. So I'm just going to go with this. So here we need to add on the other conditions as well. So what we need to check is that, okay, it's only letters, check that there are no duplicates. Okay, so this is where we actually check the equality, and we will actually make them lowercase, so it won't matter if for example our key, the letters in our key will be of different cases. For example, a lowercase t and an uppercase t. Just want to check the same thing. Argv1 I is not equal to, and just replace J here. Okay, so let's test this out actually. Oh, I have a typo here, sorry about that. Okay, so files is fine. Let's say we have G. Okay, that's an error. G, that's an error. Okay, so we're good. Okie doke. So here, basically, we are done with checking for the key and the arguments. Now we can continue, and we are here, I guess. Now let's get some space. Let's make a char array. Let's call it input. Let's give it length of 500, for example. Here we will in a good position. Nope, this one. What am I pressing? Oh, I was pressing Z. Sorry about that. Okie doke. So we're here. Printf plain text. Doke. I'm gonna give it some spacing here so it'll be cleaner. And so just print a new line. Doke. Here we could start iterating through it, and another basic for loop. So 0, I is less than strlen of input, I plus plus. Here, basically, how we can get this done is, maybe you recall from the Caesar cipher. So let's have a look at the Ascii table. So if we would have our key, which would be a string, let's say, from a character array of letters from 26 letters, so from index 0 to 25, how can we actually move a letter down there, so down to that kind of index, knowing that, for example, the ASCII code for capital A is 65? Well, we can just deduct the 65 from it. Okay, so the same for all the others that are capital case. So we can just deduct 65 and we would move it over to the index of 0 to 25, for example. For lowercase, the same, we just deduct 97. And what I mean by that is, so for example, oh, it's 4 here, sorry about that. So we have for example, we have input I. We actually want to get, let's say this is our subs alphabet, and we want this to be of position. So for example, if we have the letter A, so it's let's say capital case A, we will have A minus 65. So actually that's 65 minus 65, because the ASCII code is 65, we deduct 65. So we get position 0 here. So we will replace our capital A character with A here. Let's say it's something else, because that means there's no encryption, but we will get the index 0, so the first position here for our A letter, okay? And we will just convert that to uppercase if we had an uppercase to begin with. Okay, so that's basically it, and I hope it makes sense. You can also see it here in code. So here we can just check if input of I is lower, actually. If is lower, input of I, the parenthesis there, then input of I equals 2. So we're gonna keep this to lower, and inside here we will have argv of 1, and then the position will be input I minus 97. Okay, I think that's 97 for lowercase. 97, that should be right. So lower to lower here, so we want to maintain our case, and we will just switch input I with so we will go to the argument, the first argument, argument of position 1 actually, which will be our key, and we want to go to the position of input I. So that will be, for example, if it say that's 97 minus 97, and that will be 0. So we will get the first letter from the key. Okay, so that should be good. And then if we have an uppercase, else if is upper input of I, for that upper, yeah, that's fine. Okay, and I think I can copy this to upper. Here we will have 5, I think, for uppercase. Yep, 65, so that's good. So I think this is right. So we iterate and we check. If it's lowercase, we go to the specific position. If it's uppercase, we go to its specific position, and we also maintain case here. Okay, basically we just deduct 97 and 65 based on uppercase or lowercase to get the index for the letter that we want to get and replace our initial letter from our substitution alphabet. Okay, so I hope that's pretty clear, and I hope that I can explain it quite okay. And here printf cipher text. Here we will have our input. Here line just for space, return 0. So successful. Okay, so I hope this is right. Let's just give it a check. Okay, so it compiles. I do have some examples ready here. So let's go with this. Here. Substitution. Oh, something went wrong here. So let's see. But cipher text. Oh, we're not actually getting the input. So I forgot to use fgets. Input size of input and standard. Okay, so we use fgets to actually get the input. Sorry about that. So let's have another go. Okay, something's wrong here. Let's. Oh, we have our char. Fgets. Actually, there are plain text here. So plain text. Okay, so cipher text VAXXN. That should be right. Yep. Let's check all possible cases. So that's good. Lowercase. So substitute. Oh, that's good. Oh, that's good. Look, got a couple more here just to be on the safe side. Okay. EHBBQ, that's fine. And just one more. Substitution. Here we go. A bit more complex. Hello world. And I'm also going to input some numbers here. Just make sure that we skip those. Works fine. So JRSSB, YB, WSB. Yeah, that's fine. All right, so seems to be working. So let's go through our code again. So here we check for arguments and key length. Here we check for non-duplicate alphabet letters. Okie doke. Here we get plain text, encrypt headers. Here we output cipher text. Okay, so this is pretty straightforward, I hope. So this is where we check for having 2 arguments and the length of our key. This is where we check that we have alphabet characters and that they're not duplicate. And here we just go ahead and check if they're lower or upper, and then we just map to the corresponding position, to the corresponding index in our substitution alphabet. And that's pretty much it. So pretty straightforward. I'll also upload this code to GitHub as well. And I hope this was as much fun for you as it was for me. And if you found this interesting in any way, please give the video a like and subscribe to the channel. And I'm also waiting for, I'll look forward to your comments in the comment section below. And yeah, thanks for watching, and I'll see you around.